another strategy of integration other than use substitution would be to use long division or synthetic division to help rewrite the integral. So don't write what I'm about to write down because it's not going to work. But the idea behind this is if we were to use substitution, our likely candidate would be that numerator. We'd have 3x cubed minus x squared minus 5x plus 1. And when we find the derivative of that, we end up with 9x squared minus 2x minus 5, and it's that whole thing times dx. So as we solve for that dx, you'd end up with du over 9x squared minus 2x minus 5. And this replacing dx is not going to cancel anything out. Right? So since it's not canceling anything out, we need another strategy. So another strategy for us to work on and another strategy for us to use here would be to use long division, right, to help rewrite this integral in another way into a format that we can actually integrate. Now, I'm going to show you two examples. We're going to do one with long division, one with synthetic division, just to kind of get you guys a refresher on both division processes and see how it works with the integration. So this first one, since it's a 1x minus 2 on the denominator, it's actually a pretty nice candidate for us to use synthetic division. So when we use synthetic division, we take the denominator and we switch that sign to put it inside into that little box there. And then we rewrite the coefficients of the numerator. So 3, -1, -5, and 1. And remember, if there are any values that are missing, right? Like if there wasn't an x, we'd have to use a 0 as a placeholder there. So what we do is we drop that first one, 3 drops down to the bottom, and we multiply into the box. So 3 times 2 gets us 6. We place it in the next column. -1 plus 6 is positive 5. 2 times 5 is 10. -5 plus 10 is positive 5. 2 times 5 is 10. And then 1 plus 10 is 11 right there at the end. So basically what this means for us is this integral can be also rewritten as, after we divide, 3x squared plus 5x plus 5, and then plus 11 over, right, when we're dealing with the remainder, we put it over what we're dividing by. So this integral is really just 3x squared plus 5x plus 5, and then plus 11 over x minus 2 dx. Now, what's really nice about this is this problem is much simpler to integrate for us. We could integrate 3x squared by making this 3x to the third over 3, plus integrate 5x as 5x squared over 2. We integrate 5 as 5x. And then the 11 over x minus 2, we need a little u sub for, but since it's a 1x minus 2, we could kind of use the shortcut, which is plus 11. We know it's 1 over something, so the ln of the absolute value of x minus 2. Since the derivative of x minus 2 is 1, we'd be dividing this equation, this part by 1, which doesn't change anything. And then we have our plus c at the end. So this is our final answer. We could reduce this thing. Actually, I'm going to reduce this. We'd end up with just x cubed plus 5 halves x squared plus 5x plus 11 natural log the absolute value of x minus 2 plus c. And I'll record that as my final answer for this one. All right, next problem. Next problem, we can't use synthetic really for because of that 3x minus 5. Now, there are ways, but they just sometimes get a little bit complicated, and it tends to just be easier to work with, to end up working with long division here. So what I'm going to do is I'm going to take that 3x minus 5, and I'm going to divide it into our numerator, 6x to the fourth minus 7x cubed plus x squared plus 2x. And you might need a plus 0 at the end. You could put the placeholder there. You might need it, you might not. We'll find out as we go. And then we want to apply our long division, right? So the goal of long division is to multiply that, in our case, that first term, that 3x, by something to get 6x to the fourth. So we're going to multiply everything by 2x cubed, right? 2x cubed times 3x gets us 6x to the fourth. And then 2x cubed times -5 gets us -10x cubed. And we'll subtract these two binomials. Now, when I'm subtracting these two binomials, I like to switch those signs right away and then just add them, right? Just kind of distribute the negative, then combine our like terms. Now the first thing should always cancel out. In this case, 6x to the fourth minus 6x to the fourth is gone, cancels out. And then I have negative 7x cubed and positive 10x cubed, which gets me positive 3x cubed. Then I need to multiply something by to get that 3x cubed. I also need to bring this x squared down. So the next thing we can multiply, what times 3x gets us 3x cubed, but x squared. So we're going to multiply both pieces by positive x squared. So positive x squared times 3x is 3x cubed. Positive x squared times negative 5 is negative 5x squared. And again, we'll switch those signs and combine those like terms. So once we do that, the x cubes are gone, and we end up with 6x squared. We'll bring down that plus 2x, and again, look for that product, right? So what times 3x gets us 6x squared, but we have a 2x at the end. So 2x times 3x gets us 6x squared. 2x times negative 5 gets us negative 10x. We do that same thing. We switch the signs, and we combine our like terms. When we do that, the x squareds disappear. We have 2x plus 10x to get us 12x, and we have nothing left. So plus 0, you could write it, you don't have to, but we can do one more round of division. So 3x times 4 is going to get us our 12x, and then 4 times negative 5 gets you negative 20 at the end. And we can combine, right, switch our signs, combine our like terms, and we end up with a remainder of 20. Right, in our case, positive 20. Now, what that does for us is it tells us that this integral that we started with can really be rewritten as the integral of 2x cubed plus x squared plus 2x plus 4 plus 20 over 3x minus 5 dx. Now, as we integrate this, again, it's much simpler to integrate each of these pieces. So the integral of 2x cubed is going to be 2x to the fourth over 4 plus x to the third over 3 plus 2x squared over 2 plus 4x. And this last one we got to be a little bit careful with because of that 3x minus 5 in the denominator. So that 20 is just our coefficient of the natural log of the absolute value of 3x minus 5. But since this is kind of applying, right, there's a chain rule happening here, u substitution happening. We have to divide or multiply by the reciprocal, right, divide by the derivative of the inner piece. So the derivative of 3x minus 5 is 3. So we got to make sure we divide that piece by 3. And then a plus c at the end. Now finally simplifying this problem, we're going to end up with 1/2 x to the fourth plus 1/3 x cubed plus x squared plus 4x plus 20/3 times the natural log of the absolute value of 3x minus 5 plus c. And that would be our final integral. So yeah, listen, yes, a lot going on, but ultimately once you divide it, it becomes a much simpler integral to work with.